AC Cobra, also known as Ford Shelby Cobra, is an Anglo-American two-seater sports car manufactured intermittently since 1962. It competed in a number of road races, but because it was so expensive, it never sold in large numbers. Attempting to bring it back as a retro sports car, Ford unveiled a modernized version at the Detroit Auto Show in 2004. Researchers at the U.S. Department of Energy recently displayed yet another version, this time with electric propulsion and a plastic body printed in a 3D printer. Robert Ivester of Energy's Advanced Manufacturing Office says the goal wasn't to build a Cobra. Instead, researchers wanted a way to test several things relevant to printing large-scale objects.
The capability to balance thermal loads was an important one. The ability to achieve very, very high quality, professional grade surface finish. The ability to custom design around components that we're going to put in. So this example has one motor and battery, but we could relatively easily change over to a completely different motor and battery, powertrain, suspension system, because of 3D printing.
The flexibility of 3D printing proved to be a great advantage. Ivester says the car was built in 6 weeks by a group of 6 people at the Oak Ridge National Laboratory in Tennessee.
It's printed in about 6 pieces. There's one piece that's the core chassis and mechanical structure, and the front end and the back end of the body were each produced in a couple of pieces that were joined to each other, and then they're bolted onto the chassis.
During tests at the National Transportation Research Center, the car reached 128 kilometers per hour with acceleration of about 8 seconds to 100 kilometers per hour. Not quite as fast as cars on the road today, but respectable. The real value of 3D printing is its speed and versatility. One of the most important advantages of large-scale 3D printing for the automotive industry could be the manufacture of molds and dies for sheet metal car body parts, usually a critical production bottleneck.
With a metal mold, they're going to start from a monolithic metal block and machine away all the pieces that they don't need. And the finishing processes take long. So a typical response time for an automotive scale mold is at least 9 months. And we could do it in 48 hours with printing.
Ivester says his department is now researching whether 3D printing of molds and dies could be used to build parts for wind turbines. George Putic, VOA News, Washington.